Okay, great. I think I'm going to kick this off then. So welcome everyone. Thank you so much for coming to CARTO's final webinar of the year. I was told that I could do something really fun for the last webinar of the year because it's sort of the festive season and we're all sort of starting to wind down a little bit. So I had to think about the topic I wanted to talk about, and I decided there's only really one topic that has been on everyone's mind this year, and that is, of course, Taylor Swift's Eras Tour. So welcome to a webinar dedicated to exactly that, called Blank Spaces, pardon the pun, spatial analysis of the Taylor Swift effect. So let's get started. First of all, welcome. I'm going to introduce myself, introduce CARTO, and then we're just going to get straight into it. So a little bit about me. Hi, I'm Helen McKenzie. I am a geospatial advocate at CARTO. What that means is my job is to get people really excited about geospatial analysis, sort of inspire people, hopefully get people to see the value of why spatial analysis is really important, but also see that it's accessible and it doesn't have to be something that is really difficult and something that a lot of organizations and a lot of people can do. So that's me. And just a quick sort of 30 seconds or so on CARTO and who we are and what we do. So if you're not familiar with CARTO, we are a cloud native location intelligence platform, which means that we plug directly into cloud data warehouses like Google BigQuery, Snowflake, Amazon Redshift, and all of the analysis that you do with CARTO happens directly in that cloud data warehouse. So your data never has to leave that, which means that we are basically trying to help people really scale their spatial analysis. So our mission is to empower people with the best data and tools to unlock the power of geospatial. And a really core part of our mission is democratizing location intelligence. So we think that in the past, location intelligence has really been limited to people with sort of GIS degrees and backgrounds and people with really specific knowledge. And we're really trying to open up location intelligence to more people so more people can realize the benefit of it. So how do we do that? So there's sort of four main pillars to CARTO and who we are and what we do. So I mentioned connectivity, connecting to cloud data warehouses. That's really something that makes us really different. We also have a premium data offering. So we have a spatial data catalog, which hosts around, I think, 12,000 data sets now. I think the slide might be a little out of date. On things like financial spend, human mobility, but we also have loads of data from open sources like your censuses and demographic data, and we host it all there for our users to be able to really easily access. And you'll be seeing some of this data in action in a little bit. We also have CARTO Builder, which again you'll be seeing again in a second, which is a browser-based analytics and visualization platform. Everything that you do with CARTO happens on your browser, so you don't have to install any software on your desktop. Everything is web-based. Then we have a really core part of our offering is helping people to solve problems. We have our analytics toolbox and Python-based CARTO frames to help people with fast and automated data analysis. And finally, we have an end-to-end offering. So our CARTO users get access to our whole tech stack, APIs, connectors, Python libraries, the whole sort of thing. And that's a really quick overview of what CARTO is, but I think the best way I can explain what CARTO is to show you. So a little bit of housekeeping before I get really carried away with talking about Taylor Swift. So this webinar is probably going to be about 40 minutes, 45 minutes. We have our fantastic moderator, Jocelyn, in the chat. So if you have any issues, you can't see me, you can't hear me, anything like that, then drop a message in the chat. And also, if you have any questions, we will hopefully have about 5 minutes for questions at the end. Or if you'd rather, you can find me on LinkedIn, Helen McKenzie. I'm pretty much the only ginger person working in geospatial. So drop me a message and I'll be happy to have a chat with you on LinkedIn. So here's what we're going to be talking about today. These are the sort of three main areas that we're going to be exploring today. First of all, what is the Taylor Swift effect? That's sort of the whole premise for this webinar, but people might not necessarily know what it is. Then I'm going to be using spatial analysis to work out, is the Taylor Swift effect real? Is it something that's actually happening and affecting people and affecting businesses? And then finally, the bulk of this is going to be analysing where needs the Taylor Swift effect, where is missing out on Taylor Swift's impacts on the economy and could really do with a Taylor Swift concert. Spoiler, the answer is sadly not my back garden. So first of all, what is the Taylor Swift effect? So if you have been following entertainment or financial news this year, you've probably come across some articles like this. it's all over the news how basically huge concerts and music tours like Taylor Swift's Eras Tour are having huge effects on local economies. They're causing people to spend more in certain areas, travel more to certain areas. There's even been examples of these huge concerts having an effect on sort of seismic activity because there's so many people jumping up and down at the same time. So it's an economic phenomena, but it's also something that's affecting so many wider industries. So the Swift effect, also known as Swiftonomics or Taylonomics, it's a really big deal. So in her Eras tour, it's estimated that each show has grossed $13 million, which obviously generates a huge amount of wealth, not just for the tour, but also for the local economy. So through hospitality, retail, transit, all sorts of things. And it's estimated that in general, this is generating $4.6 billion for the US economy, which is absolutely massive. And obviously, the Eras tour is so much bigger than just the US. It covers the whole world. Sadly, not quite enough in the UK, but it covers the whole world. But in this webinar, we're mostly going to be talking about the impacts on the US economy. So while this webinar is devoted to Taylor Swift in many ways, this isn't just about Taylor Swift and the Taylor Swift effect, because all events have the capacity to change human behavior. So while it's easy to think about these massive concerts that happen in huge stadiums and also things like huge sporting events, all sorts of events can change human behavior. That could be protests and rallies, it could be a road accident, it could be transit disruption, it could be a bit of rain. All these things affect what we do, and it's really important to consider them in your organization. So this can have wide-ranging impacts on human activity. So it can mean an increase or decrease in service demand, which in many different industries. So maybe that means increased mobile data usage in certain areas. It might mean supply chain pressures increasing and services being disrupted. It could change consumer spending patterns. There could be an increased insurance claim on things like mobile phones if people are going to concerts and potentially losing their phones or they're being stolen. So there's loads of different ways that events can impact businesses. And being able to anticipate these challenges can allow organizations to mitigate risk and exploit opportunities. So this is the slide that I put in to basically be able to do this webinar about Taylor Swift, was to prove that it has business application. So now we can go on and talk about Taylor Swift in a bit more detail. So in this section of the webinar, I'm going to be exploring using some spatial data and spatial analysis, whether the Swift effect is real. Is it something that is happening and causing real change in different areas? So typically, if you are going to do this kind of analysis, what you need to do is work out what is different in areas around a Taylor Swift concert as opposed to areas not around a Taylor Swift concert. So in general, like if you were using desktop GIS software or GIS software in general, you might employ this sort of approach. So you would find all of your concert venues. You would create a buffer around each concert venue. So that might be, that's basically the area that you say, I think this area is affected by the concert. So it could be, depending on what you're analyzing, it could be a 10-minute walk, it could be 50 miles, it could be lots of different things, lots of different sizes, sorry, depending on what it is specifically you're looking at. And then what you would do is take your source data. So say, for example, you want to work out how many people live within 50 miles of a Taylor Swift concert. You would create a 50-mile buffer around each concert venue, and then you would take something like this input data set that we have here, which is census tracts, and work out the percentage of each tract that falls within 50 miles of the buffer and use that to calculate the population. So when you're working at a massive scale, like you would need to for analyzing a Taylor Swift concert and tour or anything sort of similar that has a global scale but has these really sort of local geographies attached to it, you really need to be able to scale your analysis. You need to be able to work with massive data sets. And conventionally, this is relied on geometries. So geometries are the column or the part of your spatial data that has a spatial element in it. So typically that will be a long list of coordinate pairs that describe each vertex or corner of each shape. So for example, if we take this big polygon down here, the geometry description would include a coordinate for this corner, this corner, this corner, and all say 200 corners that we have in the shape, which is obviously a really massive massive bit of data to hold. And that means this kind of analysis typically is really, really slow and expensive. And actually, a lot of organizations are changing the way they do this kind of analysis. And one way that organizations are increasingly doing this kind of analysis is using something called spatial indexes. So you might have heard these referred to as discrete global grids, or DGGs. I can never say that. I'm so glad that at CARTO we tend to refer to them as spatial indexes because that's much easier to say. But a lot of organizations use these as something called a support geography, which is where you aggregate a range of source data. So things like population data or spend data, you aggregate it to this grid. So rather than it coming in its raw form, like maybe a census tract or just point data, you have it all aggregated to this hexagonal or whatever shape grid. So the reason people are doing this is it enables really, really fast analysis and really, really light storage of data. And I'll explain why in a second. Another really key element of spatial indexes to be aware of is they're available at multiple resolutions. So the example you're looking at here is really quite a coarse resolution, but these grids can go down to something like, I think like 50 centimeters wide is about the most detailed they can get. So you can, and I think the least detailed is maybe about 50 miles wide. So there's a really, really wide variation in the resolutions. So there are multiple types of spatial indexes available for people to use. So the sort of three big ones you'll probably hear the most about are S2, QuadBin, and H3. And actually, QuadBin and H3 are probably the really, really common ones. And we're going to be seeing a couple of these in action in a second. But before we get to that, I just want to explain why spatial indexes are so powerful for the kind of analysis that we are doing. So as I mentioned earlier, most traditional spatial data is reliant on a geometry, which you can see an example of here. You can see we have the coordinate pairs, and this is about 1/10 the size of a census tract in the USA. So you can see that that would be absolutely massive to store in whatever format that you store your data in. Spatial indexes, however, are geolocated, so they have their location encoded in a really short reference string like this. And that means they're much, much smaller to store. And that means, you know, you're saving on your storage bills, but it also means that your analysis is really, really fast. So this is kind of the backbone for all of the analysis that I'm going to be showing you today. So let's move on to taking a bit of a look at the Swift effect and is it happening and how it's sort of affecting different locations. So we're going to have a look at a couple of really small examples first of all. So first of all, how is footfall affected? So are there more people in a area where there's a Taylor Swift concert spending time than compared to areas where there isn't? So I'm just going to come out of my slides, and my Slack window is helpfully blocking the things I want to show you, which is great. So the base data that we're going to be using for this quick tip analysis is from our fantastic data partner, Unicast, and they have this brilliant data set called Activity, where they have basically the number. In fact, I can show you a bit more information back on here. They have a quad grid grid. So QuadBin being a type of spatial index that is square in shape. One of the data sets that you can subscribe to via CARTO is this activity data set, which includes things like the number of visitors who spend different parts of the day in each grid cell, and the proportion of people who are visiting that area, the proportion of people who work in that area, the proportion of people who are residents. So there's loads and loads of different information contained in this grid, and I just wanted to show you before we run the analysis what that looks like. So I mentioned earlier CARTO Builder, which is our visualization platform. That's what you're looking at here. So this data set is the one that I just showed you in our spatial data catalog. It's the activity data set. So we can see that we have, if we zoom in really close, we can see that we have this square base grid, which holds what you're seeing here is it's called staying. So it's the number of people in total on an average day who spend time in each of these grid cells. And what I really love about this data set is how it's super, super detailed. So you can zoom in and see things like individual gas stations and individual roads. And then you can zoom out, and it might take a little longer because this is a very, very big data set I'm showing you. But it also covers the whole of the USA, and you can visualize this in one massive visualization, but you can also see that level of detail. I can just see I've got something in Slack. No, we're okay. Okay, great. So this is the data set we're going to be using to work out whether footfall is different around concert venues. So I'm just going to now head into the CARTO workspace, which is where, as CARTO users, you can do all of your analysis, create all of your maps. If you're interested in replicating anything from this webinar or having a go yourself, we do offer a free 2-week trial. So you can head to carto.com and just get signed up for a free trial. It takes about 30 seconds, and then you can have a go at all of this yourself. So I'm going to head into CARTO workflows down here. So CARTO workflows is our low-code interface for running analysis, basically. You can see it's kind of, in fact, I'll show you so you don't have to see from there. But it's basically a way of running multi-step iterative analysis without code, or with maybe a little bit of code, depending on what you're doing. And it makes analysis really, really simple. So just a really super quick tour of CARTO workflows. So we have here the main canvas. I've already dragged the 2 data sets we're going to be using on in here, which I'll show you in a second. You also have here on the left all of your sources. So these are the data sets that are in your data warehouse. So I've got all of my data sets in this Google BigQuery dataset. And you can also access your data observatory datasets that you subscribe to. So you can see I've got Unicast here, which is the dataset that we're using to look at human mobility. Then we have components, which is all of our sort of spatial analysis and processing tools. And there's a little bit more to it, but it will all become apparent as I continue with this. So I'm just going to show you how you could use spatial indexes to get insights about things like Taylor Swift concerts, if you are so inclined. But this sort of approach can be used to working out any sort of characteristics for a local area, essentially. So we have 2 data sets here. We have our Taylor Swift venues. Let me just preview the data view so you can see what that is. You can see we've got 42 venues and their latitude and longitude columns associated with them. And then we have our Unicast mobility data. So let's just expand that. So you can see here we have our quad bin reference, and this is where the location's encoded. So this reference is how CARTO knows where to place each cell on a map. Then we have staying, which is the average daily footfall in a location. And then we have proportion others. So these are the people who are spending time in each of these cells who don't live there and they don't work there. So they're the people who are basically, we think they're visiting the area. So the first thing we want to do is basically create an area of influence for each of our Taylor Swift venues. So the first thing we need to do at present, we can see that this data set doesn't have a geometry column associated with it. It's just a sort of flat non-spatial table. So we just need to create a geography. Let's create a jog point. So this will take the, having to move my little Slack window around quite a lot as I'm doing this. I hope it's not obscuring what you can see. So first of all, we just need to set the latitudes and longitudes for our venue. So this will take that flat data column and turn it into something spatial. Next, we want to create an area of influence for each of our venues. Now, as we're looking at footfall, I think we need quite a small area of influence. We're only really interested in the really sort of local area around a venue like a stadium. So I'm going to assign the buffer as 800 meters, which is about a 10-minute walk. And then the final thing we want to do is run something called quad bin polyfill, which is a tool that will basically convert our buffers, our polygon geometries here, into a quad bin grid. You can see something I did there just before I hit run was set the resolution to 17. That's because our Unicast mobility data is also a resolution 17. So this allows us to join the 2 together, basically, which you'll see in a second. So you can see that ran really, really quickly, which is great. And let's take a look at the results. So I'm just going to open this in the map preview so you can see what this looks like. So you can see we've now got this quad bin grid covering our areas of influence, our 10-minute walks for each venue, which is fantastic. Now what we need to do is fill that with intelligence, fill that with some information. So the way that we would do that is we're going to, if I can spell correctly, I always spell badly whenever I'm doing live demos. We're going to join the 2 together. So we're basically going to say we want to join by the quad bin IDs, which we have in both of these tables. I want to do a left join, so we're only going to retain features that are in within our 800 meter 10-minute walk buffers. So let's just run that. Now, this might take a little bit longer because you can see we're working off 28.6 million input records, which is the whole of the United States. Actually didn't take long at all. I was hoping to have a water break then, but no such luck. So now, I hope you can't see my face obscuring the screen so much, and I hope that's just affecting me. We can take a look at the results of that. So you can see we've got, as before, we have all of our input data on our stadiums, but we also have our footfall data and our proportion of visitors data assigned to each stadium. So now we just want to know the total or the aggregate that for each stadium, so we can see what that looks like for each input. So the way that we would do that is add a group by component, and this basically aggregates input variables. So we're going to group this by the venue, so the name of each stadium. Then we want to retain the geometry, so the point that we created back here in stjogPoint. And we want to, what do we want to do? Let's say we want to know the total footfall within a 10-minute walk. And we also want to know the average footfall within a 10-minute walk. And then we can also say we want to know the average, the proportion of people who are visitors. And then one other thing I'm going to just do here is add in another group by component, but I'm going to look at the whole of the United States because it's really useful to be able to compare the areas close to our venues with the wider country. So I'm just going to add in a average footfall across the US. And let's just run that. So with workflows, you can see I'm sort of running it bit by bit, but you could easily build this whole thing and run it all at the end. It just kind of depends how you like to work. I like to check that things are working as I'm going along and sort of build it bit by bit. Every time you change something in a workflow, you only run that sort of final bit that you changed. It doesn't reprocess the whole thing, which makes things loads quicker. So you can see we have our aggregation for the whole of the United States. So let's take a look at that. So we can see the average footfall within each of our quad bin grid cells is 47.5. So that's an average of 47.5 people visit that cell each day. And now let's take a look at the areas within our Taylor Swift venues. So let's expand this so you can see a little easier. So all of these ones that have nulls at the top are actually the international venues. So you can see things like Wembley Stadium in my home city of London. So we're not worried about those. We're only worried about the United States. So we can see here, actually the numbers are much higher around events venues, as you'd expect. So we can see that, for example, around the Mercedes-Benz Stadium, we have 1,729 is the average footfall in each cell around that stadium. And the total is 57,000 in that 10-minute buffer around stadiums. And we can also see that the proportion of visitors compared to non-visitors, so people who work and live there, 0.9%. So, oh, not 0.9%, sorry, 90%. So that's pretty high. So that's really interesting. So that's kind of a really quick workflow to show how you can take data on a massive, massive scale and use that to work out these really sort of local level analysis. I mean, these grids that we're looking at, these grid cells, sorry, that we're looking at here are about, I think, 200 meters in width. So they're really, really localized insights. You can get some really local insights and use that to make really local level decision making, but at sort of a countrywide scale. I mean, we could be doing this globally if we wanted to. But so yeah, so that's kind of a workflow of what that looks like. So let's head back into our slide deck and just sort of check out the results of doing this with some other data sets. So that was looking at human mobility. Now I just want to talk a little bit about consumer spend. So how does consumer spend change around event venues? So I've taken the same approach here as I just did with looking at human mobility and footfall, but looked at how spend has changed over time around these events. So not just how spend is different close to a venue as opposed to far from a venue, but also how that's changed over time. And I should also say that with this data set, so the human mobility data set I just showed you, this is also aggregated monthly. So you could do this sort of analysis with this data set as well. But we can see here, so this purple line is showing that 0 here is the month that the concert took place. So you can see that in the few months before the concert took place, we're starting to get an increase in spend in areas around the venues. I think this was a 10-mile search radius, yes it was. So we can see that in the month of the concert, there's a 10.19% average spend increase in each of these venues across the United States, which is pretty significant. I think if I was a local business, I'd be really happy with that. And that's a 9.96% higher spend, than the entire 12-month period before it. And we can also see, like, this is still quite early days because obviously the Eras tour is ongoing, so we're still getting data through about this. But we can start to see sort of there's signs of sustained high levels of spending in the months after the Taylor Swift tour. So that'll be a really interesting thing to keep an eye on. And I think another thing to keep in mind with this analysis is I think it's very easy to say, oh, but you're sort of comparing a Taylor Swift concert with times when there wasn't a Taylor Swift concert and there wasn't anything else happening. But it's important to remember that these event venues where these concerts are happening, there's events happening here all the time. They're normally huge football or soccer stadiums. There's events happening here all the time. So there's something different about this specific event. So final bit about measuring if the Swift effect is real, is just having a look at how spend in different categories differs around concert venues. So this is not looking at sort of month by month, this is just looking at in general for the past year. So we can see that within 10 miles of a Taylor Swift venue, household expenditure is 6.53% higher than areas further than 10 miles. And we can also see how this breaks down for certain relevant categories of spending. So for example, we can see public transport down here, it's about 9% higher. So people are spending a lot more to get around on public transport. We can see gifts in particular is quite a lot higher. People are buying gifts. I wish someone would buy me one from the Eras tour, but no such luck yet. And things like apparel and accessories down here, 10% higher. That's quite a lot higher. So it's really interesting to drill down into these different categories of spend around concert venues. And this data, again, can be accessed from our spatial data catalogue with thanks to our partners from the AGS. So let me just check time. Perfect, I think we're right on track. So the final and sort of chunkiest bit of this webinar is hopefully going to be a really fun exercise where we're looking at where needs the Taylor Swift effect. So where are the areas that don't have a concert but could potentially really benefit from one or benefit from similar events? They're sort of missing out on this amazing boost to the local economy that other areas are getting. I'm just going to check the chat because I can see a couple of messages. I think we're okay. I can get to those in the end. Okay, so start to explore that then. So I decided that I wanted to build a blank spaces score in line with the title of this webinar, and to basically work out where are those blank spaces, where are the people who aren't getting the benefits of the Taylor Swift tour. So there's 3 elements that I've drawn into this analysis. So first of all, financial gain. So that's a really key part of this. Where are the areas that could really use that boost to the local economy that don't currently maybe have the same levels of local expenditure that other parts of the US do? Then where is the biggest audience? So where are those Taylor Swift fans who don't live close to a Taylor Swift tour venue and would really benefit from getting to see the show, but also are most likely to really spend their cash in the local economy? And then finally, really crucially, distance to the closest venue. So where are people furthest from the closest venue? There's obviously like a lot of sort of quite tangential benefits to this sort of analysis. Like obviously, if you've got a huge audience who are really, really far from a Taylor Swift tour venue, they're going to be traveling ages to go and see that tour, which means obviously it's great for spending money on transport, but it's not so good for the environment. So there's a lot of different things you can read into this. So we're going to bring these 3 factors together to come up with a blank spaces score. So how we're going to do this? So first of all, we're going to take financial gain. There's obviously a lot of different ways that you can measure where can people most stand to gain financially from something like this. What I'm going to use is the American Community Survey poverty rate, which again, you can access for free via the CARTO Spatial Data Catalogue. So that's what we'll be using as sort of a proxy for financial gain, but there's obviously lots of different ways you could explore this, things like median income, occupation, that sort of thing. So that's point one. Point two is, where is the biggest audience? So I haven't done a survey on where are all Taylor Swift's fans based, maybe for a webinar next year, but this time I've done something a little bit different. I've done some geosegmentation. So another data set that you can access via our spatial data catalog, one of my favorite data sets, is Spatial AI's proximity data set, which classifies areas across various countries based on their experiences, their personalities, and their feelings that they share on social media platforms. And they score them against different indexes. So if they score 100, that means they are fully aligned to that index. So the index that we are going to be using for this is Girl Squad, which is defined as from girls' night out to a movie night in with their closest gal pals. I cannot stand that phrase. This segment is all about getting the girls together for an evening of fun, which to me sounds pretty much like the Swifties. So basically, if a location, and you can see here, this is based on, I think, census block groups. If a census block group were to score 100 against Girl Squad, that means that census block group, everyone living there is talking about this sort of stuff all the time. They're talking about girls' nights out, they're talking about movie nights, they're talking about it all the time. So the way that we would typically use this is take that score of 100 and divide it by 100, so it becomes a score out of 1. And then we would multiply it by the population. So for example, if we had a census block which had a population of let's say 500, and they had a score of 1, we would multiply them together, and they would have what we would call the total addressable market of 500, because 100% of the people there seem like they're really into this sort of stuff. If they had a score of 50, we would divide that by 100. So we would have a score of 0.5. We would multiply that by the population, which would give us 250, because that means that we think about 50% of people are really into this kind of stuff. So it's a really good way of sort of approximating what the market might be in these areas. And the way that we would do this is to, in a most simple level, is to use a H3 grid. So taking data from these geographies, you can see both these data sets are based on census geographies. So this first one, poverty rate, is based on census tract, and the second one is based on census block groups. So we'd use this thing called a H3, this component, sorry, not thing, to this component, enrich H3 grid, to aggregate data from those quite heavy geometry files and boundaries to a H3 grid to make them super lightweight. So I've already done that, and I'm going to show you what that looks like. Again, my Slack is blocking everything useful on my screen. Here we go. So these are the data sets that we're going to be using to create our blank spaces index. First of all, we have population. So you can see here the dark blue areas where there's an area of higher population, the yellow areas are where the area of population is lower. I just want to take a brief detour to talk about some of the really cool visualization elements of spatial indexes like H3 that you can achieve in CARTO, because they're really awesome. So I mentioned right back about 20 slides ago that spatial indexes like H3 are available in multiple resolutions. You can actually use CARTO to visualize H3 cells kind of whatever resolution you want, and it aggregates them on the fly. So at the moment you can see we're visualizing this at quite a sort of semi-detailed level, but I can use this resolution slider here to turn it to whatever resolution I want. The lowest you can have it at is the sort of native resolution. So the resolution I'm using here is 7, which I believe is about 500 meters across for each H3 cell. So that's the most detailed I can visualize it at. So you can see here I've cranked it right up to 2, which is not very useful for anyone. But I can take it all the way down to 6, which is the most detailed that I can visualize it at. You can see that will obviously be a bit slower because there's so much more data it's rendering. But you can see that now I've visualized this at much more detail. So it's a really good way of controlling the amount of information that your users are seeing at different zoom levels and stopping them being overwhelmed. I'm just going to turn this back up to 4 for a second, just to demonstrate the other really awesome element of spatial indexes and visualizing them. Sorry if my voice is a bit weird. I'm in COVID recovery mode, so I feel like I'm always seconds away from a cough. So the other element of spatial indexes that I just wanted to quickly show you is this really awesome thing where when you zoom, where should we go? Let's go to New York. when you zoom in, hopefully you can see the resolution changes. So the further you zoom in, I think that's probably, oh no, I've got another level of detail. The further you zoom in, the more detail you can see. So I think that's the most detail we can go, but if we zoom out a little bit, we can see that on the fly, the data is aggregating to a level, to a resolution that is relevant to what you're currently looking at. So you're not being overwhelmed with detail, and that really helps with decision making at different scales. So that was a brief detour into the really cool ways, things you can do with spatial indexes and visualizing them. But let's get back to sort of the main story. So these are the sort of three data components that we're using to build our blank spaces index. So we have population, and we're tying that in with the Girl Squad index. So here we can see the dark pink areas are where there's more people who are aligned to the Girl Squad index. They're the people who love their girls' night outs, their girls' night in, that sort of thing. So these dark pink areas you can see particularly along the coast down here and up here. These are the areas, the Girl Squad areas. So what we do is we bring those two things together to create our total addressable market. So we multiply the two together. So we can see here our dark pink areas are where we have a really high potential market, and our yellow areas are where that market's a lot lower. So this is great for working out where potential markets could be for you. And it doesn't necessarily just need to be for analyzing Taylor Swift concerts. There's, I think, 72 different indexes available, and they range from things like caffeination index for people who really love coffee, people who love craft beer, people who love trucks. Like there's all sorts in there, and it's really, really helpful for not just having to look at the population overall, but being able to really segment that to people who are relevant to what you're doing. So that's sort of pillar one, our total addressable market. Then we have our poverty rate, our proxy for financial gain. So we can see here the dark pink areas again are areas where the poverty rate is that bit higher. So we can particularly see in the sort of south down here that poverty rate is that bit higher. So that's sort of pillar two. Time check, doing okay. And then finally, we have distance. So we have how close are you to a Taylor Swift venue, kind of speaks for itself. You can see here, as always, it's really important to not just consider data within the geography you're looking at. So we've also got data looking at things like Toronto, which is just outside the US. But obviously, if you live up here in this sort of northeast part of the US, you're probably quite likely to go to a gig in Toronto as well. So those are our three pillars that we are looking at to run our blank spaces index. So let's take a look at how we would do that. If I can find the right tab, here we go. Perfect. So what we've done, if I just take you back a step, is we've enriched our H3 grid with our total addressable market and our poverty rate. So the final thing we do is just this section here. I won't talk through every element of this workflow, just with half an eye on time. But this section here is basically calculating the distance from every H3 cell, so every 1.8 million cells covering the United States, to the closest, the distance from those to the closest Taylor Swift venue, and then just joining the two back together so we can have that level of intelligence, so we can relate the two to each other. The bit I do want to take a bit of time to explain is the score. So this is how we're creating our blank spaces score. So the first thing I've done here is I've filtered out, hopefully you can see here, all the areas which have a population of less than 10. Assuming that, you know, we wouldn't really be want to be holding a massive concert where there's a really, really low population density. We need a level of population to support that concert. The next thing that we would do, and there's lots of different ways that you can do this, and I'm going to show you this and then a couple of other options in a second. But this is one of the simpler ways you can create a score from a few different variables. What we really need to do is, if I just take you back to here, just to look at the data we're feeding into this, we have our three variables we're interested in. We have our nearest distance, we have our poverty rate, and then we have somewhere along here our total addressable market. We need a way of bringing those three variables together into one score to basically be our blank spaces score, be able to bring all that information together. At the moment, they're three completely different measures, and there's no way to bring them together. So what I just do here is normalize each of them, which basically takes that range of data and scores each value a score from 1 to 0. So 1 being like the highest total addressable market, 0 being the lowest. So then we can bring all of those 3 normalized indexes together in here, this final column, this final component, sorry, which is create column. And what I've done is I've taken my 3 normalized indexes, multiplied them by 0.33, and then added them together. So this will give me a score out of 1, 1 being the ideal place to have a Taylor Swift concert, where the total addressable market is really high, the poverty rate is high, and the venue is really, really far away from the closest other venue. What's really good about this kind of approach is it's very simple, but what's really good about it is you can really easily weight it. So you could change these values to whatever you wanted. You could have this as 0.5 and these two as 0.25. You can change those up and weight it how you want. So with all of that run, and you can see I've pre-run this already, just with time in mind. Let's take a look at the results and take a look at our blank spaces index. So I'm just going to go here into the map preview and hit create map. I've lost my tab. I think we're in the right one. Great. So that's just going to take a second to load. And you can do this with any component in a workflow. So you can click on any component, hit create map, and it will generate something like this. So here we have our H3 index. You can see we've got the areas that we filtered out, which have a population of less than 10. So let's just really quickly style this up to see what the results are. So I'm going to select my fill color to be index, which is the column I just created at the end of that, at the end of the workflow, sorry. And let's just choose a really nice girly color in line with the topic. I'll change that to quantile so we can see. So this is the result of our analysis. Pretty cool, right? So the dark pink areas are areas which are most in need of a Taylor Swift concert. So those are the areas which have a high level of poverty, they have a high number of fans, or potential fans, sorry, and they are really far from existing concerts. So that's a really, really quick way that you can do this kind of analysis and bring sort of variables from different data sources and geographies and measures together into one score. I'm just gonna, before we get to the end of this session, I'm just gonna really quickly show you another way that you can do this. If I can find the right tab, here's the right tab. Okay, let's just close this window for a second because that's spoilers. So there's a few different ways that you can measure this. As you can see when we look at our blank spaces index, which is this layer, we can pretty easily eyeball this and say, oh, this area around here looks like it really needs a Taylor Swift concert, these areas too. But actually, it's so much better if you can quantify that kind of analysis and actually really be able to say, no, I can confidently say this is the right area. So one of the ways you might want to do that is doing something called hotspots. So hotspot tools work out where there are statistically significant areas of high values that are clustering together. One of the things that CARTO offers our users, if you remember right back to, I think it was slide 3, I talked about our analytics toolbox, which is the range of functions and tools that we offer our users to be able to get the most out of their data. One of the modules in that is statistics and has all these fantastic data science components in that, one of which is a combined hotspot tool. I think it's actually called commercial hotspots. And that's where you can take in different measures into one hotspot tool, and it comes up with a multivariate hotspot. And you can also weight within that. So you can say this variable is much more important than this variable, and that's really, really helpful. So this is the result of what that looks like. And you can see what this is great at is it sort of filters out all of the noise, and it says, these are the areas that you should be focusing on. These are the most important areas for people who are deprived of Taylor Swift concerts. I nearly said conferences then. Conference season's on my mind. So that's another approach to this sort of analysis, that more sort of statistical approach. The final approach I want to show you is one that I think is really game-changing. My background is working in GIS consulting, and I feel like the vast percentage of my time was spent sort of doing faff work at the end of some analysis, where I would run an algorithm, I'd run a model, I'd present it to my manager, and they'd say, yeah, it's good, but can you tweak this little number or tweak this little element of it? And what I'm going to show you is a really great way of sort of not getting around that, but streamlining that process. And it's something called parameters, which is where you can basically set these inputs here. So you can see we've got an input here for each of our pillars of our index, if you will. So we have total addressable market, we have the distance, and we have the poverty rate. You can allow users to input values into these. That can be then fed directly into the SQL code and act as a placeholder and modify the SQL code. So I'm going to show you how right now. So down here, you can see in CARTO Builder, we have all of our sources. So this is all the data and all the queries and all the tables that you're seeing on the map. So I'm just going to open the SQL editor for the index that I have on the map here. And hopefully my laptop is zoomed in enough that you can see this. But can you see we have our little section of code here that calculates the index. This is our blank spaces score. And you can see we have our 3 pillars. I don't know why I keep calling them pillars. I think it sounds quite good, which contribute to that. So we have our total addressable market, and these are all pre-normalized. We have our nearest distance to a venue, and we have our poverty rate. And then can you see how we are multiplying each of those to this little section of code here, which is enclosed in the curly brackets. So this section of code here directly relates to whatever is input in here. So if the user changes the value that's input in here, this value changes. So if the user changes this to 1, this will change to 1, and it will recalculate the entire index. So let's take a look at that in action. How should we change this? Let's change this to look at just distance. Let's make it really simple. Just to illustrate this. So you can see we're loading data sources, and that means it's recalculating this whole thing. And it will take a couple of seconds because it's doing the whole thing over again. So you can see how that has just regenerated that whole layer by recalculating the whole index. So that's really helpful for if your end user wants to really get involved in the data and they want to be able to fiddle around with it. They are maybe likely to request all those changes to the analysis that you've done. They can come into your end map, and this is all shareable on a public map. So when you go to share your map like so, you can include the sharing the SQL parameters, which is what these are, and the end user can play around with those themselves. So they can say, oh, I'm not interested in distance that much, let's take that down. I'm really interested in where the fans are, and I'm quite interested in the poverty rate. So they can change all those up. It will load the data sources, take a second to recalculate it. That didn't look right. There we go. And it will calculate the index based on the inputs that they want. So this is obviously a game changer for saving time, but also engaging your stakeholders and getting them to get involved. It's not just numbers that you can include. So you can also do textual parameters. You can include date parameters. That's really useful for if people want to be able to filter data to certain time periods. So I think that's a really, really powerful way of taking this analysis and making it something that gets people involved in spatial data, which is what we all want. So that's kind of the end of the demo section of this. I just had a couple more final sort of thoughts to end on. So just to kind of what would be next if I was going to do a little bit more analysis on this, or try and use this to solve some business problems. So potentially I would take those hotspots that I calculated and say, where are there event venues within those hotspots? Could I potentially, not that I have the power to, but if I did, could I potentially include a concert in one of those venues? Also, there's, like I mentioned, there's lots of different methods of calculating these sorts of multivariate scores. I just showed you a couple. Another one is running spatial composites, which is a great, really sort of quantitative way of taking all these different variables together and bring one final score out of them. If you're interested in running spatial composites, I really recommend this blog post that I've just popped on this slide here, using spatial composites for climate change impact assessment. So it's focused on climate change, but really you can use the information in there to sort of extrapolate that to any use case of your choosing. And then finally, maybe if I didn't have the power to choose where Taylor Swift had her next tour date, maybe I could have some satellite events in some of the areas that we pinpointed. So things like having big, really massive screen showings of like the Eras film. I feel like I see in the news every day another video of people being really annoyed at people dancing in the cinema to these screenings. So maybe there's an appetite. In fact, there's definitely an appetite for having some like massive screen showings of these types of things. So that kind of takes me to the end of my presentation. I hope you liked it. Something a bit fun and whimsical to end the year on, hopefully. If you're not Taylor Swift's tour manager, hopefully he or she is with us today. But if not, I'm hoping there's still something that you've taken away from this that is valuable to you, because I think so much of this is actually really transferable across a lot of industries. I mean, it's quite a sort of whimsical use case, but I think there's a lot to learn from the kinds of things we've been talking about. So, for example, events, and not just global music talks, but all sorts of events, whether it's the weather, whether it's a traffic accident, whether it's a football game, soccer game, they can impact virtually all industries. So everyone should be incorporating them into the kinds of analysis they're doing, whether it's operational, whether it's strategic. It's something that affects everyone. Secondly, spatial indexes. I feel like I've talked about them an awful lot today, but they really are such a game changer if you're wanting to run analysis at scale. So today we were talking about really local level analysis, but also on a national scale, one of the biggest national scales you can operate at, the United States. So they're really, really game changers for doing that sort of work. And then finally, that just end point that we spoke about, so building end user parameters into your analysis, is really, really helpful for saving everyone time, helping with stakeholder buy-in. There's so much that they are really, really useful for. And just a little final plug, if you did look at the analysis and the visualizations I was making with those spatial indexes and thinking, wow, I really need to try those out, we have a report called Spatial Indexes 101, which you can get on the CARTO website, and there is just so much information about spatial indexes in there to help get you started, if I do say so myself, because I wrote it. But there's so much in there, so I really, really do recommend popping by carto.com and giving that a download. And that is pretty much everything for me. I'm just going to, I think we have maybe 2 minutes. I'll just see if we've got any questions. Like I said, if you would prefer, feel free to drop me a line on LinkedIn. My name's Helen McKenzie. Do feel free to drop me a line. So let's have a look. So, sorry I'm confused, but the hotspots tool calculates automatically the right weight for each of the 3 variables. No. So the hotspots tool by default weights all of the variables the same. It's for you to define what the right weights are. There's obviously methods that you might want to employ to work out what those would be, but it's for you to input what those weights are. So thank you. We also do have a single variate hotspot tool. So we have Getasord and Local Moran's Eye. We also have a blog post explaining all about that recently on our blog post. So I recommend giving that a read if you're really interested in hotspots, because they're, I swear, one of the most useful tools in spatial analysis. So thank you, anonymous attendee. Okay, I think one more question, because it's 54, and if I'm not by 55, I'll be in trouble. For the distance to venue analysis, would it be better to use drive time analysis than straight line distances? That's a really, really good question. So it really depends on the geography of what you're looking at. So if you were looking at, you're trying to analyze something around more local geographies, so things like stores or coffee shops or fuel stations or something like that, then I think drive time would be really, really valuable to use. And we actually have isoline tools at CARTO, so if you want to create those sort of more realistic catchments based on the actual transport network, then drive time indexes are really useful. I'd say with this specific example, drive time analysis wouldn't be as important, just because there's so few. I mean, we saw there's 42 venues across the whole world, which is a massive music tour, but actually in terms of the geography it's covering, there's so few venues that actually people are going to be flying, people are going to be taking the train to venues, so drive time is probably a little bit less relevant. I think it would still be something useful to build into analysis, but a little bit less relevant for something like this. So I think that's pretty much all we have time for. Just one final really quick question, where someone asked if we'll be sharing the recording of this afterwards. Yes, absolutely. So you'll get an email from our fantastic marketing team who will share a link, to this webinar, and you can watch it as many times as you would like. So yes, absolutely, you'll get some, and I think some links to some of the resources I've mentioned as well. So I think that's pretty much all we have time for. Thank you so much for coming onto this webinar. I hope you enjoyed it. I hope you found something useful and educational, and not just me talking about Taylor Swift for an hour. But yeah, thank you so much for coming. Please do feel free to drop me a message on LinkedIn. Happy to discuss anything that was mentioned here. And I guess if it's not too early to say, happy Christmas. And yes, thank you for coming.